So let's begin with the transistors. There are two types of transistors, PNP and NPN. These are the two types of transistors that we need to know. So what are the differences between these two? How are we going to differentiate them? So when you check their shape, for example, when you check the shape of the NPN transistors, if the arrow coming from base to emitter, this is base, this is emitter, that means this is an NPN transistor. If arrow goes from emitter to base, that means this is a PNP transistor. Okay, this is the difference between these two. If you want to differentiate, if the arrow goes from base to emitter, it is NPN. If it goes from emitter to base, it is PNP transistor. So to find the current gain for transistor, we are going to use this formula: collector current over base current. This will give us current gain HFE. Okay, it's going to give us current gain in a transistors. So there are logic gates. Logic gates, we learn about like 5 types of logic gates, OR and NOT, NAND and NOR logic gates. I'm just gonna talk about like 2 of them to just give you an idea about the logic gates. So the rest of it you can just check it out in your notes or in the videos that I shared you before. Okay. So for example, this is an AND gate. What does AND gate do? An AND gate has 2 inputs. As you see over here, there are 2 inputs. AND gates looks like it looks like a D shape. Okay, there is an output over here. When you connect to the input like 5 volt potential difference, you're gonna get a reading of 1. Okay, if it's not connected to 5 volt potential difference, you're gonna get the reading of 0, like here. For example, here A and B connected to they don't connect to the 5 volt potential difference. That's why their readings are 0. So output voltage will be also 0. On the other hand, when you connect one of them, still you're gonna get an output voltage 0. Okay, so to get the high volt, like to get the maximum of the AND gate, you must connect A and B, the 2 inputs, to the 5 volt potential difference source. Okay, when you do that, you're gonna get a reading of output 1. That means there is going to be conduction in the output part. Okay, this 0 stands for no conduction. This 1 stands for there is conduction. Okay, so on the other hand, there is an OR gate. OR gate looks like a spaceship, as you see over here. It looks like a spaceship. So again, there are 2 inputs over here and 1 output over here. OR gate, it's like vice versa of the AND gate. Remember, for AND gate, we need at least 2 of them must be 1 to get 1 output, like to get conduction in output. Both input must connect to this potential source difference. For the AND gate, one of them is if one of them is connected to the potential source difference, we are gonna get a reading at the output. Okay, so except 0, 0, all of the readings are, all of the combination are going to give us an output current. Okay, let's continue. Unit 6, types of the waves. Let's first talk about transverse and longitudinal waves. These are the 2 types of waves. Okay, longitudinal waves, they vibrate parallel. Their direction are parallel to the motion of the wave. On the other hand, when we talk about the transverse waves, their motion is 90 degrees, is perpendicular to the motion of the wave. Okay, and the direction of the energy, as you see over here, from left to right. So let's continue. There are longitudinal and transverse wave, it said, but there are 2 types of wave that we have to be very careful. We have to know about them. Mechanical waves and electromagnetic waves. These waves are totally opposite to each other. Electromagnetic waves is a type of transverse wave. So electromagnetic waves do not need any medium, any material to travel through it. They can travel through air, okay, through vacuum. But on the other hand, when we come to the mechanical waves, they travel through some medium. Okay, there should be material. So they travel through best in solid, then liquid, then gas. Okay, mechanical waves. They have a frequency, period, wavelength, and amplitude. Mechanical waves transport energy, but they cannot transport material. Okay, they can transfer energy. So what is the relationship between frequency, wavelength, and speed? The relationship between when we find a speed of a wave, we are going to multiply frequency and frequency and wavelength. Okay, when we multiply these two, we are going to get the speed of the wave. So to get the speed of the wave, here V stands for the speed of the wave, F stands for frequency, and this lambda, this Greek letter lambda, stands for wavelength. Okay, so one of the important thing is in order to get an electromagnetic wave, any moving charge can be enough. Okay, when there is any moving charge, this is going to happen in electromagnetic waves. Okay, so here there is electromagnetic spectrum. This is important. Why is important? Because when the light moves from visible part to the left, this part, the frequency and the speed of the waves will increase. Okay, when it moves towards right, on the other hand, the frequency and the speed of the wave will decrease, but over here, as you see, the wavelength will increase. Okay, these are the some type of waves like gamma rays, X-rays, ultraviolet rays from sun, infrared rays, and microwaves. This is generally used for cooking. And radio waves we generally use for communication. Okay, for communication, watching TV, we use radio waves. Okay, we need radio waves in order to like watch or listen to radio. Okay, watch TV and listen to the radio for the communication. So visible light, as you see over here, it's very like small. It starts from purple to the red, as you see. So the purple one has the smallest wavelength for the visible light, and the red one has the highest wavelength. Okay, that means the purple one is faster than the what do you call it, red one. Okay, due to when you send the white light to a prism, you are going to see the refraction there, and light will like disperse into 7 different colors. Okay, due to refraction. So reflection, don't confuse the reflection and the refraction. Okay, reflection means like when you send the light through to a surface, if light bounces back, this is called reflection. Okay, the light is going to bounce back. It is not going to pass through the material or medium. Okay, this is reflection. So for example here, let me give you an example. Let's say you send a light ray with 45-degree incident ray to the mirror. Okay, this ray is going to be reflected with 45 degrees, and it's going to hit with 45 degrees to other mirror. Okay, 45 degrees, 45 degrees, 45 degrees. The ray of incident will be the same for this ray. Okay, for all the rays, the ray of incident will be the same. Okay, so let's continue. And as you see over here, when you send this light ray, incident ray 45, incident ray 45, there is a normal over here. Remember, normal divide the rays into 90 degrees, like into 2 parts. So it is 90 degrees. As you see, the ray of reflected will be 45 degrees over here. There is another example over here. For example, when you send with the 30 degrees again, the incident ray in the second mirror will be 30 degrees as well. Okay, incident ray here again, it's going to be 30 degrees. As you see over here, it becomes 30 degrees. You send with 30 degrees, it is going to hit other mirror with the 30 degrees, and it's going to be reflected with 60 degrees. Okay, the reflected ray will be 60 degrees. Okay, don't forget that the ray of incident must be equal to ray of incident on the other mirror. Don't forget this. Okay, so refraction, on the other hand, we said the reflection, the light bounces back. For the refraction, the light doesn't bounce back, but the light passes through the other medium. Okay, there are going to be 2 medium. For example, it could be air and water. When the light rays come from air to water, they are going to refract. That means they are going to bend towards the normal. Okay, this is called refraction. Refraction, the light passes through the pass through the medium, and it passes the other side of the medium. But for the reflection, this does not happen. Okay, reflection happens on the mirrors, refraction happens on the lenses. Okay, now lenses again. For lenses, there are 2 types of lenses. Okay, before going to lenses, let's talk about a little bit about mirrors. There are 3 types of mirrors: plane mirror, concave mirror, and convex mirrors. Okay, concave mirrors and convex mirrors, they are curved mirrors, but plane mirrors is not the curve. Okay, Don't forget that. Plane mirror is plane, it's straight. And on the other hand, there are two types of lens. We are going to talk about it. The first one is convex lens, which is, we call it converging lenses. Why converging? Because they converge the light rays. Okay. The second one is concave lens. We call it diverging lens because they diverge the light rays. Okay. So in the lens, refraction happens in the lens. Don't forget this, refraction happens. But in the mirrors, reflection happens. Okay, in the mirrors. So in order to form image, we need two light rays. Okay, the rays that I show you, you have it already with yourself, like parallel ray sending from the center or from the pole of the lens. While you send those two rays, you are going to see an image formation on the other side of or in front of lens as well. Okay. So what do we use the converging or convex lenses? We use for magnifying glasses, eyeglasses, but fixing farsightedness. Okay. If you are talking about nearsightedness, we use concave or diverging lens. But for the fixing the farsightedness, we use convex lens. Okay. For cameras, we use converging lens, and for microscope, we use convex lenses. Okay. So what about diverging lens? Let's summarize the diverging lens. First of all, image is going to be located on the other side of the lens. Okay, it's going to be a virtual image, an upright image, reduced in size. Upright means erect. Okay, upright means erect. Reduced means diminished. Don't forget these terms. Okay, so what does this mean? This is going to be happening for all object when you use a diverging or concave lens. Okay, but for convex lens or the converging lens, we cannot talk about a proper summary. Okay, that's why you need to know this only for concave lenses. Okay, for diverging lenses. So where do we use them? Where do we use these lenses? We use them for flashlights, lasers, projectors, peepholes, glasses. Okay, glasses. Uh, Glasses. We talk about farsightedness for the converging lens, but for nearsightedness, we use concave lenses. Okay, diverging lenses. So this, if you have myopia, okay, it's myopia. This sickness in your eyes, you are going to use a concave lens in order to fix it. Okay, in order to fix it, you have to use the concave lenses. All right. You guys see here the mirror equation. Okay, this mirror equation is important. Okay, the mirror equation. In order to find the location of image or object or like focal point, we use this formula: 1 over s object, the distance of the object, plus 1 over distance of the image equal to 1 over the focus of the mirror. For example, there is an example over here. A mirror has a focal length of 200 millimeter, 0.2 meter. If an object is placed 0.6 meter from the mirror, where will the image be formed? Okay. So in order to find this, we are going to use this formula: 1 over focus equal to 1 over object distance plus 1 over image distance. When we do this, 1 over 0.6 plus 1 over si equal to 1 over 2. When we send 1 over 2 over here, when we subtract it, we're going to find 1 over si 3.33. But this is 1 over si. So you have to flip-flop this. When you do that, you're going to find 0.3 meter, the distance of the image from the mirror. Okay, that means 300 millimeter is going to be behind the mirror. Okay, so this formula is important. I want you to just